By the way, what is a polar coordinate system and what is a rectangular coordinate system? So that's the essence behind this video. Let's say we have a point P with, let's say, a coordinate given as x, y. This is what you call the rectangular coordinate system. This is the system where the point has been presented with its coordinates given as x as well as the y. This is what we call the rectangular coordinate system. And what is the polar coordinate system if this is the case? Let us present this actually a rectangular system on the Cartesian plane. Let's say we have this case. Now this is the x-axis, should be y-axis, and this is the x-axis. Let's say this is x, and let's say this is the y, and say this is the point of interest, which means this is the point P with coordinates given as x, y. Let's say the distance drawn from the origin to a point P, it is given as, let's say, r. Let's say from the origin to the point P, it is given, let's say it is given as r. Now, what is the angle in which the distance r makes with respect to the x-axis? Let's say it is given as the angle theta. Let's say that's the case. So, the point P can be presented in the polar coordinate in this form. It is given as the r, theta. Theta, it is the angle in which the line r makes with respect to the x-axis, where r is the distance from the origin to the point P. So keep that in mind. So how can we have the value of r, which is the distance from the origin to where the point P is? So we use the distance formula that will be given as r is equal to x squared plus y squared. And how about the angle theta, which is given as this? So we calculate the angle theta using the trigonometric ratios. That is, we should have this. Now what we have, it's a right angled triangle now, where this is actually, we have this as x. By the way, this is x, and this is the y. So using the trigonometric ratios, this is opposite, this is the adjacent. So which means we'll have it as a tan theta is equal to y over x, which is, now if we'd like to have the angle theta, we'll have it as theta is equal to the tan inverse of y over x. So this is the formula that used to have the value of the angle theta if that's the case. So this is what you call the rectangular coordinate system, and now this is what you call the polar coordinate system. So keep that in mind. Now what if we have, let's say, the rectangular coordinate system given us, let's say, a point P with given us r, let's say theta. Let's say this is the rectangular system, should be a polar coordinate system. How can we have this to be in a rectangular system? Mind you, the point P will be denoted as P s, y in the rectangular system, where x will be given as r cos theta, and the y will be given as the r sin theta. And from the understanding of the trigonometric ratios, you will be able to have this as that. So where theta is the angle itself, and the r is the distance from the origin to a point P. So take note of that. Now let's say we have these problems. Let's say we have a point N with point N, actually M, in a rectangular coordinate system given as 2, 2. What is this in the polar coordinate system? Mind you, this is x, we have x as 2, and we have y given as 2. Now in the polar coordinate system, we'll have it as r, actually theta, where r is given as the x square and plus y square, that will be given as, that should be 4 plus 4, that will be given as the square root of 8. And of course you can also have it in the actual decimal form. And how about, let's say, the angle theta? We'll have the tan inverse of 2 over 2. So what is the tan inverse of 2 over 2? So 2 over 2 should be the tan inverse of 2 over 2. We'll have it as 45 degrees. So which means the angle is given as 45 degrees. Now the polar coordinate will have it as the square root of 48 should be the square root of 8, 45 degrees. So that's how we make it possible there. And what if we have, let's say, a point P in a rectangular coordinate system given as, let's say, -5, let's say 3. What is this in the polar coordinate system? So we have x being given as -5, and we have y being given as 3. So now, which means we'll have it as r, theta. That is a polar coordinate system. What is the r? We have it as the square root of x squared. That will be given as 25 plus 9. So what is that? This is the same as having it as, now should be the square of, now we should have it as square root of 34. So keep that in mind. And what is the angle theta? We'll have the tan inverse of, now should be 3 over -5. So what is the tan inverse of 3 over -5? So we have it as -31. We'll have -31 degrees. So which means we'll have it as a square root of 34, -31 degrees. So take note of that. Now what if we are given in terms of the polar coordinate system, and I told you have it is in a rectangular coordinate system. Let's say we have a point M that is given as 25, let's say 30 degrees. What is this in the actual rectangular coordinate system? So now the point M will be given as x, y in the rectangular coordinate system, where x is given as the r should be a cos theta, and y will be given as the r given as the sin theta, where r is given as 25 and the theta is given as 30 degrees. So take note of that. So now have the x being given as, upon substituting, you'll be able to have what is x and what is a, actually what is y, and present actually aim in terms of those values you need to calculate. So bear that in mind. And let's say, what if we have a point, let's say Q, given as, let's say 21, let's say -61 degrees. What is this in the actually rectangular coordinate system? So try to have that an out at your own time. And sometimes the rectangular coordinate system can also be given now sometimes the polar coordinate system can also be given in this form, can be given as, let's say, can also be given as this, where this is the angle theta, and let's say this one can be given as, let's say, given as r. So having this one, it is the same as having it as r, theta, which is true more given as the polar coordinate system. So bear that in mind. So try to have the following conversions. Let's say we have a point W given as, let's say 2, -20. What is this in the polar coordinate system? Try that on. Let's say we have O with -20, let's say -30. What is this in the polar coordinate system? So try to have these conversions at your own times. Thank you.